11.3 from magma in the mantle to lava on the land. So we have near most of the plate boundaries and weak spots in the crust, there is magma in the mantle, which rises and pools in those chambers within the crust. So we have things such as vents, where it provides a pathway for that magma to rise to the surface. And once it's at the surface, it is then called lava. All right, and that flows out and along the pyroclast, and it creates ash clouds. We also have craters, which may form at the top of volcanoes after powerful eruptions. So we'll see a little bit more of this in detail. Volcanoes can occur at divergent boundaries, like the Icelandic volcanoes at the Mid-Atlantic Ridge, can also occur at convergent boundaries, so those subduction zones like the Ring of Fire, and then at hotspots, so those areas where we have a break through the weak crust. So that would be our Hawaiian Island volcanoes, as well as Yellowstone, which is a supervolcano. And as I talked through that, Ms. Lepore kind of pointed out some of those ones at the bottom. So if you need to rewind real quick to understand which ones are where, please feel free to do so.
Yeah, so Iceland on the left, you've got there, Ring of Fire here in the Pacific Ocean, again, bordering that close to all of our continents as well. And then the last two pictures showcase some of the geysers at Yellowstone. And so you can take a look at those. And then obviously the Hawaiian Islands themselves are the result of volcano production.
So we have three different types of volcanoes that we'll talk about. One of them being a shield volcano. So that has a low viscosity and fast flowing lava. Some of these vocabulary words are also at the top. So maybe take a moment and pause the video so you can look up at the top of the descriptions of a lava. So you understand the viscosity, the kinds of eruptions, and what's associated with which ones up there. So please feel free to go back and check that out. But again, those shield volcanoes have low viscosity, fast flowing lava. They are gently sloped and more flattened. And you'll see this more with the Hawaiian Islands and the Galapagos Islands, as well as in Iceland. Then we have composite or stratovolcanoes. Those are high viscosity lava. They are more cone-shaped and steep-sided mountains, like Mount Etna and Mount Rainier. And then we also have cinder cone volcanoes, which are steep stacked of pyroclasts as a result of one major eruption, one of those being in Mexico. Support's going to say that for me.
Paracution.
Thank you. And the other one is Wizard Island in Oregon, part of Crater Lake.
And just a quick moment here, this word viscosity basically has to do with how thick that lava is going to flow. So think about the difference between something that flows quickly is going to have a low viscosity. So something like baby oil, all right, or water would have a low viscosity. So that lava is going to flow fast, all right? Something that has a high viscosity, it's going to flow slow. So think of it more like molasses or honey, something that's going to take a little bit longer to be able to flow. And obviously that's going to make a difference when you have a volcanic eruption, because that's going to, matter in terms of safety. It's going to matter in terms of evacuation. It's going to matter in terms of length of time for the eruption and all that kind of stuff. So one characteristic of volcano eruptions, but a very key one. So do make sure you take a look at that, like Ms. Kay suggested.
All right, and then here we have some of the volcanic eruptions of some of the places that we have actually been to. That one over there on the left is the Valley of Fire in Nevada. And then do you want to go over the ones in Iceland that you have in Scotland?
Sure. So you can see a moss covered, and most of Iceland is either covered in some type of lava volcanic eruption, or it's covered in glaciers, literally the land of fire and ice. But this is a moss covered lava field located in Iceland. And then these couple of pictures in the bottom on the left are from the Isle of Staffa in Scotland, on the west coast of Scotland. and that's Fingal's Cave, and then the Coolin Mountains on the Isle of Skye, again, also formed from volcanic eruptions as well. And then Santorini, Greece. We talked about that with geomythology, hypothesized to be the land of Atlantis, but you can actually see the giant crater that was this volcano and the leftovers that became the beautiful island of Santorini there as well.
And then in the top right there, we have Giant's Causeway in Northern Ireland, which we also have talked about a little bit during our geomythology. And then on the bottom right there is Yaquina Head in Oregon. Those are pebbles that were shaped that way due to the lava that was coming through and cooled, and then shaped that way because of its travel through the water.
And then my favorite volcano story, which is the eruption of Mount Vesuvius in Italy in 79 AD, destroyed Pompeii, the city of Herculaneum, etc. So here you're looking at a picture of Mount Vesuvius, and the other pictures are showing you some images. You know, Pompeii was excavated, you know, fairly recently in terms of the full excavation. They just actually did another excavation of Pompeii. We'll be talking more about that in our activities, but you can see because you're talking about a day cycle pretty much for the eruption and in terms of the destruction of the city, but completely covered in volcanic ash. And so basically it essentially became preserved, you know, in that volcanic ash. And so as excavations happened over the last century and a half, you can still see the mosaic tiles. You can still see the coloring on the homes and the businesses and the amphitheaters that were there in that city. But you can also see the people that died there. Again, considering the time frame, considering the belief in gods and their anger towards people being exemplified through volcanic eruption. They thought they displeased the gods, and so they were, you know, set for their punishment. They didn't really evacuate probably in the best way. And so a lot of people were still in the city. And again, the speed of that eruption also contributed to that. And so what you see here with all of these are called plaster casts. You see various people of different ages. You can see a child here. You can see someone protecting another, probably child here, the way that they're curled up and laying, sitting there and probably praying. Basically what happened as people started to excavate, they would get to a spot and there would be an opening. And so what they ended up doing is pouring in plaster cast to fill the space that the person would have taken up in that volcanic ash, and then carved out around the plaster once it dried. And then they were left with these people, these images of these last moments of the people of Pompeii. The person, obviously, considering this was 79 AD, has already biodegraded over time, you know, and their bones were most likely there. But again, they themselves were not, but we can still see the image of these people. It's a very powerful message about what geology can teach us, not only about volcanic eruptions, but also we can see some evidence of life a very, very long time ago. So definitely an interesting area of study for a little archaeology as well. Alrighty, in addition to the amazing things and terrifying things and earth-changing things that volcanoes do, earthquakes is another disruption in geological terms that can really cause some upset. And if you'd like to kind of keep tabs on the latest earthquakes, we have a link there in the upper right corner for the U.S. Geological Survey that essentially monitors earthquakes around the world. And so you can, any even small measurements of earthquakes, we can see and keep track of there. So we'll probably pull that up a couple of times during this unit just to kind of see what's going on in the world. Basically, what happens in an earthquakes is, remember, our tectonic plates are constantly moving, even though they're moving very, very small distance-wise in terms of in our time frame. And they generate friction, right? You have these rough, huge, large pieces of rock moving against each other, into each other, underneath each other. And basically that creates friction, just like as if you were rubbing your hands together or you were trying to drag two things across each other. And basically, as that happens, that energy, right? We're storing energy because we're we're essentially trying to do some work on these rocks as we move. And so all that potential energy, all of that energy gets stored up. And then eventually one little movement causes those rocks to actually finally shift past each other. And that's when that potential energy gets converted into kinetic energy, and the rocks break, and you have all sorts of movement happen. And we feel that as an earthquake, all right? We feel that as an earthquake. And as you can see in the images here on the bottom right, as well as what we're gonna see in the next few slides, lots of devastation can take place from a short amount of time with these earthquakes. So where are they happening? Well, very similarly to volcanic activity, they're gonna happen at divergent boundaries. So anytime you have plates moving apart from each other. Convergent boundaries, right? So we saw with oceanic and continental, oceanic and oceanic, as well as continental and continental. So again, that ring of fire that we've talked about a few times, these are the earthquakes that you tend to hear about. I know this year, just very recently, there was another, I think it was a 7 point, but I'm not recalling that off the top of my head at this moment, that just happened near Japan, again, very near the same place that we'll see in a minute. I think it was the really bad one in 2011 that generated a tsunami. So they just went on tsunami warning because of that earthquake that occurred. And then they also happen to transform boundaries. So at those fault lines, that's why California is very notable for earthquakes because of the San Andreas Fault. And if you didn't know, here in Illinois, there's actually a fault line, a crack in the crust, and that's called the New Madrid Fault. So there are times, I think in my lifetime, I've felt it at least twice, where there have been some tremors from an earthquake from that fault line, which is very interesting. In terms of some vocabulary, so we understand when we look at or hear about earthquakes, they usually use terms like the focus and the epicenter. And so basically, the difference between these two things just has to do with location. So the focus is the point underground where the earthquake began. So literally like the point where the rocks went and moved past each other. And that's your focus. So that's our originating point underground. And then you have the epicenter. So directly above that, but on the surface of the land, on the crust, that is where the epicenter is. And we usually hear about the epicenter of the earthquake. And that means we focus on that because that is the location where you're going to have the greatest ground shaking, right? Because it's literally the point on land directly above the focus, all right, that original spot for the earthquake. But this is the part that's actually on land where we would have buildings or houses or where we would live, okay? So when we study earthquakes, the people who actually study them are called seismologists, and they're called that because they study seismic waves. So these waves that are radiating out, you see them in these circles, it looks like a target. These waves that are radiating out in varying directions, sometimes they go up and down, sometimes they go side to side. And those waves of movement of energy as they move through are what seismologists are going to measure, right? And they're going to measure them on a seismograph, and that's what you see pictured in the bottom on the right. And they record two things. They record the amplitude, so how big, right, did the wave, how strong was the wave, and the time. So what's the time difference in terms of how long that wave was causing disruption? And to be accurate, they triangulate their data, probably something you've heard in a movie. Triangulate just means they use 3 different spots, 3 different locations to gather the data from. And then they're able to make some predictions about where earthquakes might happen in the future because they've gathered all this data, but they don't know when, all right? There's very, very little warning when it comes to earthquakes, right? And how we measure earthquakes, when you hear about them in the news or on Twitter or wherever you hear about them, we measure them in many ways, but the most common is something called the Richter scale. And basically it lets us know the magnitude. So it's going to look at amplitude of the biggest wave that gets released from that focus and the distance that earthquake was from where we're measuring it. All right, and that's going to give us that. And so you can see here in the upper right-hand corner on the top, you can see the range of Richter scale of magnitude there. So obviously as we get into that 5, 6, 7, 8, 9 level, you can see on the side kind of what types of damage are typical. So that Richter, that 7.0, earthquake on the Richter scale there, that's enough, for for a decent amount of damage. That's going to take quite a bit of repair time. All right. And that can be some serious level there of problems. And not only that, but they can also trigger some other issues like tsunamis, which Ms. Case is going to talk about momentarily. Here are just some images and some quick data, some quick statistics on some of the worst earthquakes within the last, I don't know what we have here, 10-ish years, something along those lines. You can see a few of them, a couple in Asia, again, that ring of fire resulting in quite a bit. Again, a 9.0, this was the one that triggered that tsunami in 2011. I think there's a movie based on that. Maybe Case will remember when she talks in a minute. In 2010, there was the Haiti earthquake, huge number of people injured in that as well. And then in 2015, in Nepal. And again, it's not just the amount of people who are killed in these, but also the amount of people impacted. And you can see 8 million people impacted by that 2015 Nepal earthquake. So definitely a lot of devastation can take place and a lot of infrastructure damage that needs to be repaired, not least of which is the loss of life or injury that happens with them.
So also real quick on that website that Ms. Laporte pointed out, I believe it was slide 22, you can go on there and click on some of those places. And it looks like there was just one recently in New Zealand that ranked it at 8.1. And then it goes in and it tells you a little bit more information detailed on it. So they're kind of cool if you do find this interesting to go in there and take a look at some of that other information. It talks about like, did you feel it? Would they feel this one? And what kind of results happen as this has happened, or how many have occurred in this area. So you can go back and take a look at some of the history of some of those areas, even if it was just from this year, even though it was short, there are lots of earthquakes that were happening. So definitely take a look at that when you have some free time, because they're pretty cool to look at. So getting back to that, we've got tsunamis. This is pretty much underwater earthquakes happening. So these big waves are generated by the underwater earthquakes. They are normally coming from the convergent subduction boundary. So I know Ms. Laporte talked about that. Waves can reach 435 miles per hour. All right, and the height of these waves can reach up to 82 feet. Once that wave hits that land, it can travel for miles inland. That asterisk that's there is a great video for you to watch to give you a little bit more understanding. It gives you a good depiction of what is actually happening in that underwater earthquake, how that happens, why it's happening, and what happens once it reaches the land. And then that picture there on the right is actually a picture I took when I went on a vacation to Oregon. They have a bunch of signs that are along the road there off the Pacific coast. That say like tsunami shelter, meeting point, because if a tsunami happens, you got to get to the highest point of the land in that area. And then it kind of gives you some information there about what's happening in that area, what to do, what are some of the results that are happening. So it's pretty cool, but again, we would never obviously want that to ever happen.